so here is MM2 module that we are going to run using Excel. In this case, we are hiring 2 mechanics instead of 1, and their arrival rate, the demand is the same, 2 customers, 2 cars per hour, and the mechanics efficiency is the same. They can handle 3 cars per hour, and the wage, they pay $15, and waiting cost is about $50 per hour. And for this one, I have set up everything for you. And let us do the calculation together. For example, P0 is very complicated, and that's a starting point because that's quite complicated. We have to do this calculation first. And what I did was look at this formula. It is 1 over and this first part of denominator and the second part of denominator. And so I divided them and put them into a separate columns so that we can tackle them one by one. Putting them in one cell was too much. It was not possible. Although some other people might be able to do that, it was too complicated. So the strategy that we adopt here is to calculate these 2 denominators separately and add them up and combine them together. So let's look at the left term here, which is sigma n equals 0 to n equals n minus 1 over n factorial and lambda over mu to the power of n. So that's the first part. And second part is 1 over m factorial and lambda over mu to the power of m, and the mu, m times mu divided by m times mu minus lambda. So that's also quite complicated formula. So we are going to divide them and concord them together. So the first thing is that we want to apply this formula. It is 1 over n factorial, right? 1 over n factorial. We use a formula called factorial, F-A-C-T, and then parentheses, and K20 is this one, right? So the factorial of this is n, so 0 goes in there, and then multiply by power of this, right? So we are going to use the power function, that's exponential function, power and parentheses I4 divided by I5. So I4 is, as you know, that's lambda. If you scroll up, you'll see here's I4, that's lambda, and I5 is mu, and I have entered that here. So I4 over I5, and then comma, K20 means this is n is right here, and to the power of n, that's going to be n. So I use that, and then I found that that's going to be a 1. And the second one, in the same way, what I did was I used this dollar sign to fix lambda and mu, and K21, well, n is keep on changing. It keeps on changing, so I left it as it is, and I just scrolled it down or double click on this square, then it will copy all the way down, and therefore I have these values over there. And then the cumulative sum of left term at n minus 1, right? So we need to sum them up together because we have this sigma function, and I'm starting from 1 here because we have to go from n0 to n minus 1. So that's why I'm starting with the second row, and here is L20. I'm going to just bring that value as it is, and then on the second one, I'm going to add this one and this probability together, and then I have 1.66, and then the third one, 1.66 plus 0.22, and that gives you 1.88, and here 1.88 plus 0.049, that gives 1.93. So you can just copy it down, then you see it is converging onto 1.947734041, right? So that's what we see. in this part. And then I'm done with this left term, this term. And mine is, since I have only two channels, I have to go to only 1.66. That's all I have to go to because my channel is only two, not 5 or 20. So that's why I'm stopping here. And then I have now to go to right term. So here's 1 over m factorial times lambda over mu to the power of m, and m mu divided by m mu minus lambda. So that's the value here, and I have that here. So let's apply the formula. So 1 over factorial mu, which is 2, and that's K21. And remember that I'm using this formula only, but later I will have to use these 0.33 values. But to just simulate all the values for this denominator, that's why I'm using K21. And power to the power of I4 is lambda, I5 is mu, and I fixed the cell. I used the absolute reference there. And to the power of m is right here 1, so that's K21. And times again m times mu, m is given here. I'm simulating it, so that's why I'm using 1, and times I5 is mu value divided by, so notice that I used parentheses carefully because it's very easy to make a mistake and have wrong calculations later. So divided by K21 mu, which is right here, and I5 is mu, minus I4 is lambda. And I calculated that, I copied that down, and here is the values for that. And therefore, now I am almost ready to solve my P0, find the P0 value for all the possibilities when I have different values of channels, 1, 2, 3, 4, 5, and so forth. So let's calculate that. So that's I have to add these two, and then 1 has to be divided by the sum of these two terms. So 1 over simply this plus that, and that will create 0.33 for n is 1. And if you just copy that down, it will converge on 0.51341707. And for our value, we find that this is 0.5. So let me highlight it. So 0.5 is our value because we are looking at m equals 2, right? So we find that the probability that we will have no cars in the system is 50%. That's what we found, and that's what I have entered here, right? So I used the VLOOKUP function and then found that 0.5 there. And L, we have to calculate L. L is given here as lambda times mu times lambda over mu to the power of n, and divided by m minus 1 factorial m mu minus lambda squared times p0 over here plus lambda over mu. So that's why I calculated p0 first, because to find L and other things we need to find p0. So that's the formula that I used. I'm not going to go walk through it, but you can take a look at it. And basically, I just translated this formula into Excel. And I found that's a 0.75. So 0.75 customers are waiting in the system. So that's a very short system. Very good. Now LQ is again here. LQ is L minus lambda over mu. So if you found this one, 0.75 minus lambda over mu, I calculated, and then that's given here, right? So notice that I named the cell as a lambda, and then mu as mu, and then just enter that formula there. and 0.83, 0.08 is actually customers spending the time in there, and the average number of customers in the queue right here is W P22 divided by W, because we have this W function is quite complicated, but it comes down to L over lambda, right? So we have L over lambda that will give you the value. And then WQ is Q22 over lambda. So that's given here. LQ over lambda is given here. So LQ over lambda will give you the value. So once you have everything right, then the next is easy, because you just need to enter the data and everything will be calculated for you. And here's rho value. Rho is lambda over mu times m times mu, and that's m is right at 2, and times mu, and lambda has to be divided by that, and that gives you 0.33. So 33% of the utilization in the system. So that's what we find in this system. Let's take a look at the total waiting cost. Total waiting cost is MCS. It's we have 2 people who are working, and one daily working hours is 8 hours, so 8 times, and 2, I-16 is 2, and I-7 is CS, which is $15, and that produces $240 per day to run these 2 lines. And we have total service cost, that's lambda times WQ times CW, and also it's 8 hours, right? So we have to add 8 hours times lambda times WQ, which is 0.0417, if you look at 0.0417, and multiply by CW, which is $50, and that gives only $33.33, because we are not running any very small degree of wait time there. So therefore, total cost is $273, which is much less than the others, right? So that's what we find through this MM2 model. So MM2 model is much more complicated calculations, and I encourage you to use this template that I created, and you don't have to struggle with it, right? So just use this one, then you don't have to struggle with entering all this data into or formula into this spreadsheet. Okay.